Here is another example, example 1. An insurance company wants to know if the color of a car is related to the number of moving violations. So you hear sometimes that if you have a wrecked car, the cops tend to pull you over more often. So this insurance company is wanting to know if that's necessarily true. The following contingency table gives the results of the data they collected from police reports of 443 moving violations. So we know we have a total of 443. So we're going to do a test of independence here, and we have quite a bit of work to do before we actually get to the test. So in part A, determine the expected value for each cell. Well, before we can even get to the expected value, we have to know the totals. So if I add up this first column here where the cars have just a few moving violations of 0 to 1, I end up getting a total of 231. That next column adds up to 161, and the final column is 51. So you're welcome to pause the video and add them up and make sure you're getting the same numbers. Now going across, for white, the total number of moving violations, whether it's 1 or 2, 2 or 3, or more than 3, I'm getting 122. For black, 73. For red, 108. For silver, 67. And for other colors, 43. And again, you can double check yourself. Your row total should add up to the overall total as well as your column total. For the expected value, remember we have to take each row total and column total and divide by the overall total. So for white, this first cell with 76, I would take 122 times 231 and divide by 443, and I get 63.62 if you round. For 33, I would do 122 times 161 divided by 443, and I get 44.34. And then I'll go ahead and fill in the rest of these. 1405 over here, and you're certainly welcome to check these out on your calculator. 3807, 26.53. Finishing up here with, double check that one. I have one little error. This should be a 73. So that means okay, so that's 38.07 there. Finishing up 26.53 there, and 8.4. Up here, I messed up. So 12 should be 12.43. Got going a little fast there. 7.71, and for the last one, 8.4. Okay, so that takes care of part A. I have all my row totals, all my column totals, and then filled in each expected value by multiplying the row total times the column total divided by the overall total. Now for part B, so this is A. For part B, we're going to state our null and alternative hypothesis. Remember, the null always has to do something with independence, so here I would say the color of the car is independent of the number of moving violations. So for the alternative, rather, we would just say that they are dependent. So we could say the color of the car is dependent on the number of moving violations, which seems a little odd to me. I think I would say the other way around. The number of moving violations is dependent on the color of the car, but I think you get the general idea there. Next, we need to calculate the chi-square test value. So again, this is where I would let my calculator help me out. I would put all the observed values in list 1, so starting with 76, 44, 50, 33, 28, so on, and I wouldn't make separate lists for each column. I would just put all of the observed values in one list. So that's going to end up being a list of 15 items long, and then in list 2 I'd put all my expected values, 63.62, 38.07, and so on, and then I would let list 3 do the calculations for me. And if you do all that, again, you might want to pause and see if you come up with the same thing that I get. I get chi-squared is equal to 15.4. For part D, we are going to use alpha equal to 0.01 to test, so I need to get my degrees of freedom here. Remember, the degrees of freedom are the row minus 1 and the column minus 1. But we have how many rows? 1, 2, 3, 4, 5 rows, so that's 5 minus 1, and 3 columns, so 3 minus 1, which ends up being 4 times 2, so my degrees of freedom are 8. Now if I go on my chi-square table here, I would go down to 8, and then I'd go all the way over to, what did we say our alpha was? 0.01. So down to 8 and over to 0.01, it looks like we are getting a value of 20.09. So back over here, my chi-squared, when I have 0.01 as my alpha and 8 degrees of freedom, is 20.91. So if I were to draw a little picture of that, let's try that again. So here's 20.91 and my rejection region. And we had a value of 15.4, which does not fall in that region. So for my conclusion, I would say we fail to reject H0, which basically says the color of the car is independent of the number of moving violations, or vice versa. Okay, so again, let your calculator help you out with calculating chi-squared. You do want to double check that you have everything typed in correctly, but especially you want to make sure that the observed values match their respective expected values, because if that doesn't happen, then it throws everything off. But otherwise, once you find that chi-square test value, get your degrees of freedom from the row minus 1, column minus 1, multiply those two together, look up your value and see if your test statistic falls in the rejection region, and then make a conclusion from there.